I have written a step-by-step guide to help you determine whether a solution containing a neutral salt will be acidic, basic, or neutral. This guide is available on Blackboard. Let's go through it quickly and then do some examples. The first step is to write out the dissociation reaction. So this might look something like CD reacts to form C plus and D minus. So here we have a cation, which is a positively charged species, and an anion, which is a negatively charged species. The second step is to identify which ion might be acidic and which might be basic. This is very simple. Cations may be acids and anions may be bases. So I will write here acid, question mark, and base, question mark. So let's start by looking at the cation to determine whether it is an acid. The first step is to determine whether it is a metal. If it is a metal cation, then it is an acid. If not, we must continue to step B. For step B, we determine what the conjugate base of the cation is. This might look something like this, COH, which we would get from reacting C plus with OH minus. Next, we ask whether this conjugate base is a strong base. From your memorized list of strong bases, you will determine whether this is a strong base or not. If it is a strong base, then the cation, C plus, is not an acid and is neutral. If the conjugate base is a weak base, if it is not on that list, then the cation is an acid. Either way, we know whether the cation is an acid or whether it was neutral, and we can move on to look at the cation or the anion to determine whether it is a base. So the first step, again, is to look at the conjugate acid of the anion, and that might look something like this, H plus plus D minus. Again, from your memorized list of strong acids, you determine whether this conjugate acid is a strong acid. If it is a strong acid, then the anion is neutral. If the conjugate acid is a weak acid, then the anion is a base. Now that we know whether the cation is an acid and whether the anion is a base, we can determine whether the solution overall will be acidic, neutral, or basic. We do this by adding the two terms. Here's a table showing the possibilities. If the cation is an acid and the anion is neutral, then the solution overall will be acidic. If the cation is acidic and the anion is a base, then the pH of the solution will depend on the acid dissociation constant and the base dissociation constant. I will not ask you a question like this on the exam, so we can ignore this possibility for now. The two remaining possibilities are that the cation is neutral and the anion is neutral, in which case the solution will be neutral, or the cation is neutral and the anion is a base, in which case the solution will be basic. By following these 5 steps, you can determine whether any neutral salt will dissolve in water to form an acid, a base, or a neutral solution. So let's do the 3 examples that I gave you already as extra practice. The first of these was potassium nitrate, KNO3. So our first step is to write out the dissociation reaction. KNO3 will dissociate in water to make a potassium cation and a nitrate anion. So remember, the cation might be an acid. We ask that question, and the anion might be a base. So first, is potassium a metal? No, it is not a metal, so we go on to the next step. The conjugate base of potassium is potassium hydroxide, KOH. We have memorized our list of strong acids and bases, so we know that KOH is a strong base. Therefore, K plus is neutral. Now we go on to the anion. Nitrate. The conjugate acid of nitrate is HNO3, nitric acid. Again, from our lists of strong acids, we know that nitric acid is a strong acid. Therefore, the nitrate anion is neutral. Now that we have figured out whether potassium is an acid and whether nitrate is a base, we can add those together and say neutral plus neutral equals neutral. A solution of KNO3 of potassium nitrate is neutral. It is not acidic or basic. Let's go on to our next molecule. Our next salt is here, FeClO4,3. So this will dissociate to make iron 3 plus and 3ClO4 minus. So again, we want to know whether our cation is an acid and whether our anion is a base. So iron is a metal. Therefore, it is an acid. So we're done with the cation. Now we go on to the anion. The conjugate acid of ClO4 minus is HClO4, perchloric acid. This is a strong acid. Therefore, ClO4 minus is neutral. Now we can add these up to determine whether the overall solution will be acidic, basic, or neutral. So we have an acid. Iron 3 plus is an acid. ClO4 minus is neutral. So acid plus neutral equals acid. The solution is acidic. All right, finally, calcium chloride, CaCl2. This dissociates to make Ca2 plus and 2Cl minus. Ca2 plus, calcium is not a metal. Its conjugate base is CaOH2. This, we have memorized, is a strong base. Therefore, Ca2 plus is neutral. It is not an acid. Looking at the anion, the conjugate acid of Cl minus is HCl. HCl is a strong acid. Therefore, Cl minus is neutral. Now we can add these up, and once again, just like the first example, neutral plus neutral equals neutral. The solution is neutral. I hope that this tutorial and the accompanying guide is helpful for you as you study for exam number 1.